Welcome to Global Risk Community Chat. Today our guest is Sharul A-Rashid. I'm very happy to have you here today, Sharul. Welcome.
Thank you, Is, for the opportunity, for providing me the opportunity to share my experience. Thank you.
Yes, of course. I'm very happy that you are here with us today. So before we jump into the topic, can you briefly introduce yourself?
Sure. My name is Sharul A-Rashid. I am currently the president of International Society of Automation, ISA, Malaysia Section. I'm also the PETRONAS Group Technical Authority and Custody Engineer Instrumentation and Control. I've been in this area of specialization for the past 30 plus years in oil refinery, gas, liquefaction, petrochemical, including pipeline transmission operation. And I'm now advising PETRONAS group-wide on instrumentation and control issues of their assets. At my international level, I'm assisting in developing standards in the area of instrumentation and control and automation. Example, right now, I am the co-chair, a certification work group of Open Process Automation Forum. I am the vice chair of the ISA Global Cybersecurity Alliance, ISA GCA. I'm also holding a vice chair Instrument Automation Standards Subcommittee IOGP, and also the steering committee for JIP Territory Standardized Specification for IOGP. Thank you.
Yeah, sounds a lot of responsibility, a lot of experience, super nice. So with that being said, let's jump into the topic. What would you like to discuss with us today?
Oh, today I would like to discuss about, of course, risk, because we are in the global community risk, right? Yeah. So I would like to touch on very specific to process safety, or sometimes we call it functional safety in the instrumentation world. So process safety or functional safety at the workplace, and how we manage the risk to as low as reasonably practicable. To put in perspective, from 1971 until 1998, there have been 28 numbers of process safety related incidents, and some even caused multiple fatalities. For example, Bhopal incident, 1984, 3,000 people killed by the poisonous gas during the Union Carbide India limited process safety incident in Bhopal, India. We have also an incident in Chernobyl nuclear power plant, and also 3 Mile Island in the US. All these can eventually draw total deaths of about 4,000 people in the Chernobyl. And the history repeating, from 1990 until today, process safety incidents still occur. And despite the frequent occurrence of related incidents, many of us still do not realize the hazards associated with it.
Yeah. So I'm hearing a lot of important things, of course, like the safety, especially when it comes to some critical infrastructures I am hearing. So with that being said, the topic is very important, but what are some most important things to focus on this topic, or some key things in this topic?
Yeah, because I'm from instrumentation and control, of course, I'm gonna be very specific in my area of specialization. And through this platform I would like to raise awareness of the community, the importance of compliance to process safety in accordance to the international standards and codes. For example, we have this IEC 61511 functional safety instrumented system for the process industry sector. For your information, IEC stands for International Electrotechnical Commission, an international standards organization that publishes international standards for all electrical, electronic, and related technologies. The functional or process safety standards that govern us the use of technology to comply to process safety requirements. And in this platform, I would like to focus on the process safety of terminal tank farms, product movement or operations. Okay, the terminal tank farm comprises a large number of tanks, mostly filled with flammable hydrocarbon liquid, example, LPG, naphtha, diesel, petrochemical, and other products. Operations of the tank farm involve movement of these products from tank to tank, from tank to ship or ship to tank, or from plant to tank, or tank to the plant. So the major process safety risk of these operations is the tank overfill or overflow. If you at home, for example, at home, if you fill your cup with water from the tap, it is okay if the water overflow. It is just an overflow. But can you imagine if you try to make it overflow at the real life, at the tank can be overfilled during the product transfer. It's highly flammable, and the flammable product can become evaporate and form gas cloud. And this gas cloud can be ignited and explosion will happen when ignited. So it will result in multiple fatalities, asset and environmental damage. And to address this risk we must design the tank so that it will not be overfilled when you do the product transfer. It has to be designed, for example, installed, tested, and commissioned, operated and maintained by operations in compliance with the process safety international codes and standard, of course. And furthermore, the overfill protection system must be validated and verified throughout its life cycle operation to ensure that the overfill protection system will operate on demand. Sadly, this is not being complied with. Many companies, they don't comply this requirement. For example, in December 2005, during the Barnesfield process safety incident in the UK, due to failure of this system, overfill protection system, the terminal tank farm burned, for 5 days, resulted in 43 injuries, USD 1.2 million loss, and causing 2,000 people evacuated. This was followed by 2009 massive tank farm explosion at the Caribbean Petroleum Terminal facility near San Juan, Puerto Rico. So this is very sad, Therefore, these process safety incidents around the world due to this tank overfill protection system failure, for me, is a major concern for my company to be addressed critically. So in this regard, for my company, for example, for PETRONAS, my function is to analyze my company's terminal tank farms and make sure that the tank overfill protection system project is being implemented. A simplest tank overfill protection system comprises a level sensor, safeguarding level sensors, and feed pump, the pump that actually pump the product from the source tank to the destination tank. And this level sensor, which is located at the destination tank, will continuously measure the product level. And if the product reaches certain maximum, it will alarm the operator, right? And the operator will quickly stop the feeding pump from overfill. This is a simple process. Level alarm triggered, our operator will stop the pump. But if the operator did not stop the pump, then it will overfill and catastrophic, multiple fatalities due to cloud explosion. So this is my job. I want to make sure all my plants are having this tank overfill protection system in place. Back to you, Ace.
Yes. So thank you for sharing that. I think there's a lot of information that our audience should be taken away from that. With that being said, if you were to share one takeaway point with our audience, what would that be?
Of course, one thing is remember, if you go back to your plant, for example, you at the tank farm, you watch the operator do the tank overfilling, that tank product transfer, make sure that they will not overfill, because this overfilling, overflowing can be catastrophic, can form gas cloud. The gas cloud can get ignited, explosion can happen, multiple fatalities, asset damage, and also environmental damage. So we must make sure that we convey this message continuously to observe good process safety management at the workplace. Thank you.
Yeah, sounds pretty good. Then I have one last question remaining, and that is how it is for you to be being part of our community.
Oh yeah, this is a very good platform. That's why when you offer me to share this experience, I quickly grab this opportunity, because I'm, for example, I'm the president of International Society Automation, Malaysia Section. Automation is associated with risk management. So I will share this opportunity with my members so that they can also benefit from the good thing that you guys have been doing.
Yes.
Keep continue the good things.
Yes. Thank you so much for that remark as well. I really appreciate it. And with that being said, we are unfortunately out of our time. So thank you so much for joining us today, sharing your expertise on this very important topic, of safety, essentially. And yeah, thank you so much.
Thank you. Thank you for having me.
Yes, have a great day.
You too. Bye.